Well, here's today's item of interest. This is a rather inexpensive, this is the cheapest one they had. It's an LED bulb from the local Home Depot, Homeless Despot. It was, I think, around $14, which is why I bought it, because I wanted a number of lights. I have a couple lights I leave on at night, and I wanted to use a few of these to basically kind of for security lights. So I picked up a couple LED bulbs because they were on sale, and it was a pretty good deal. It's made by ECS. This is a 8-watt bulb, supposedly, which is 75 milliamps at 120 volts. Risk of electric shock, dry locations only, blah blah blah. LED. So you can see it's got a diffuser on it. Here we have one that I put in a plastic baggie and hit with a hammer, just to get the glass off. They glue the glass on very strongly because most of these are not isolated. So the line, basically the electrical connections here are effectively connected to one side of the line. And what with American wiring standards, there's no guarantee of knowing which side is neutral. So they just insulate the crap out of the whole thing. So effectively you can't contact it. I've actually been using this with the lid broken off quite successfully for a number of weeks because the sconce it's in is in a place where you can't really touch it, and so it's not really a problem. You can see that since it's an 8-watt light and there are 16 dies here, which means each one of these individual LEDs is 1/2 of a watt. 1/2 a watt. They're actually rather interesting. I'm not even too sure what this package is. I mean, I'm familiar with most of the surface mount packages and some of the exotic ones they use in LEDs, and I actually haven't seen these before. It's kind of interesting. And you can also see that this is Rev A. So there's also to be seen as a lot of heatsink here. The cover glass is siliconed in, so you can actually see there's remnants of the glass down here. I could probably break more of it out, but it's not really worth the effort. One thing of note is these things do get very, very warm. They probably run maybe 70 degrees Celsius, to the point where it's uncomfortable to hold them, even despite the attempt at heat sinking. The heat sink's kind of amusing because you can see that it seems like there are holes up here so that the air kind of flows through, but if you look at one of the assembled ones, those holes just go into the... Well, I guess that would theoretically provide airflow inside of the glass bulb, but in effect the end result is that this doesn't really do much of anything. I mean, I have them installed vertically in the sconce so they're pointing upwards, and they still get quite warm. So I am going to see if we can take this apart. I kind of want to look at what they're using internally. I'd like to keep it working, but it wasn't that expensive, so if I break it I'm not going to be totally crushed. It's still rather warm. Yeah. So it's just got two... Oh wow. The entire thing is held together by these two screws because this is actually coming loose. Well, that's nice construction. I was worried that this was going to be glued because a lot of these things are glued together. So let's see. You can see the rather not wonderful soldering job they have done on here. Actually, is that a lump of solder just sitting there? No. Oh, yeah, it is. They just like blobbed off some of the solder and it was just sitting, held on by the rosin. That's good and good design. Just fell on the table somewhere. Here it is. So there's just like a little solder ball, probably hand soldered by some poor guy in China for like 50 cents an hour. So I think what we have here is an aluminum core, a metal core PCB. It looks like it is epoxied down, and there's definitely thermal goo in there. I think it's thermal goo. Wow, look at how melted the wire is. Also of interest is it appears that this is solid core wire. That's a little better. So this wire is not stranded, which I guess is fine considering they probably were not expecting these wires to flex ever. But I wonder if thermal cycling would cause stress issues on that over time. Actually, it looks like these are either fiducials or rivets. They're fiducials. The board just came free. There is no heatsink pierced in there at all. Which isn't that surprising considering the fact that I don't think the heatsink would be very effective. So, they heat sunk it, but the heatsink isn't very effective, so they didn't bother heatsinking it very well. Also, I think the wires are the predominant thing holding us together, because as I pull on this, it kind of pulls the socket back into the bottom. I don't want to have to dig out my soldering iron. I normally do all of my soldering at work if I can, but I don't work for the next day, so just because I don't have a lot of space. Small room, small apartment. See if I can't kind of peel this epoxy back, or silicone. Kind of cut it free. Up. There we go. The board is now basically exclusively held on by the wires. Yep. So there we go. So there's the LED board. It's maybe there is some heatsink compound. Yeah, there's heatsink compound on there. There's just not very much of it. All right, 1 second. All right, my iron should be at about temperature now. I want to try and do this without tinning. Not sure. The thermoregulation circuit in my soldering iron's kind of crapping its pants. The display went a long time ago. There it goes. That's nice. One of the nice things is solder does not stick to stainless. So you can stick a stainless soldering iron, or a stainless tool in a hot solder joint and poke around, and nothing bad will happen. When you're doing surface mount stuff, it's a great way to kind of, oops, just one little thread. I think this is probably lead free, which is why it's being grumpy. Ugh, such a bother. Anyways, so there is this with the wires desoldered, bend them upwards, and let's see. Well, look at that. There's our potted LED driver. That's obnoxious. Here's the board. Oops. So you can see that there's heatsink compound on there, and that is not very well applied. Look at how little contact that's making. The compound is hardly smeared out at all. So that is really bad engineering right there. And they've got all that. I mean, admittedly, as useless as the heatsink is, it's not even being used. You can also see it appears somebody wrote on the bottom of this with a Sharpie. Some sort of a pen. Let's see if I can't kind of trim back the silicone. There's not much in there. You can just see this is like a cast. It feels kind of like aluminium, but it could be like an aluminium injection mold, or it could even be pot metal. I mean, considering how little surface area it's got, I think the reduction in, thermal conductivity from it being, not a pure aluminum compound wouldn't, affect it significantly. So here is the wonderful soldering job in here. You can kind of see there is the big electrolytic, it looks. Let's see if there's anything in there. The issue is this was literally on about 10 minutes ago, so I have to be careful. This is like it's not ceramic, but it kind of feels like it. It's a plastic. It's like a high temperature plastic, I think. So anyways, you can see there's one end of the power transformer. Let's look at that. There's a film cap that's bent over to make it fit in the tube. There's some sort of tape in there. You can see some diodes poking out on that corner. Yeah, I guess I'm not going to put this thing back together because it is going to be taken up. Well, that's nice. At least it shatters nicely. So it'll be pretty easy. So there we can see it looks like they've wrapped that capacitor in a little bit of capped on tape. I wonder what prompted that. I wonder if they... So it looks like there's a big electrolytic, which is what these two leads go to. And it's got some sort of wrapping on it. Presumably to, I don't know, make it so that... Well, I wonder, it's potted and you've got an electrolytic, so what happens if the electrolytic fails? It would vent into where? I think the whole thing would just explode. I mean, unless it's a bottom vent, but even then... I mean, what would it do? It would... I mean, it would vent into the enclosure. I wonder how they handle stuff like that. I mean, maybe they buy... I mean, there are no such thing as non-rupturing electrolytics as far as I know, just because... I mean, you've got a liquid electrolyte, and if you put too much power in there, you get a whole bunch of gas. Basically, period, end of story. There's not much you can do about that. Fortunately, the epoxy seems to kind of not be very strong. It just kind of falls apart. I guess I'll probably turn this into a light of some sort. Assuming all the diodes are in series, which is probably a safe assumption, I can just probably drive it. I mean, I know the power. Drive it with low current, measure the voltage drop, and then you can, you know, extrapolate up and then back off a little bit, because I bet they fudge on the numbers. I mean, this did come out of China. Even if it is sold in, you know, a local big box store, I don't think anyone ever evaluates these things for, you know, how well they conform to their stated lux levels. Especially not the cheapies. I mean, maybe like the General Electric ones, but even then they're still made in China. So, you know, use off-bin LEDs or something, it wouldn't surprise me. You can actually see that's rather nice. Look at that, they've got like diagrams of what's there on the board. So it's repairable once you get all the potting compound off, which utterly involves destroying it. You can fix it if you break it first. But then of course, who's going to bother fixing a $12 LED bulb? I mean, aside from me maybe. But then I guess the LEDs are the expensive part, and they're probably also the part that would fail first, assuming there's no design flaws in the circuit, just because the phosphor goes bad over time. The color conversion phosphor that gives you the white light. Hallelujah. There we go. Gotcha. Success. So there we are. Free from the potting compound. Or the casing. Oops. In a second it'll be free from the potting compound. Oh yeah, there we go. So there is the bare ballast. hopefully the epoxy will come off fairly easily. Keep saying epoxy when I mean silicone potting compound. Close enough. It doesn't seem very adhesive. Oh. So I've kind of kept poking away at this, trying to get the epoxy off, and this is very interesting inside. It looks like they have substituted a through-hole part for some of the surface mount parts, kind of at some late stage in the production process, because this is soldered onto surface mount pads. Ugh. Typical high quality production. Fortunately, the resin seems to be more or less just peeling off. There we have partially stuffed components. Oops. So here's this, this is just a bog standard 35 volt 470 mic electrolytic. It's just been wrapped in Captain. I don't know why. Here's this film cap. It's all bent over. Let's see if some of this silicone will come up without doing too much damage. You can see what I was saying about all of these pins. They're all quite long. Here's presumably the controller. It's too small to really hope to get any part information off of it, I think. I'll have a look in a minute. It's got little bits of silicone stuck everywhere. Presumably this is either a power device or a rectifier. It could be a little tiny bridge rectifier. And considering it's labeled BR1, I would bet that's the AC rectifier. So that takes your input AC and gives you presumably some very high voltage, which is probably somewhere over on this. There's a capacitor for that somewhere on the other side. Up a little bit. Get some more light on the subject. Oh, here's the power device, I think. Looks like there's a TO263 device down here. Oh, look at that. The epoxy appears to have pulled a lot of the writing, or at least pulled some of the ink off of that film capacitor. So there's two ways this could work. It could just work directly, or it could be a linear DC and then like a constant current source. So I really strongly doubt that, because they're pinching pennies and cutting every corner on these sort of things. So if they can cut the number of parts down, they will do it. It's TO252, I think. It's labeled D1, so that... Oh no, it's Q4, not D4. Oh, yeah. Seems like it would probably be a perfectly functional ballast. I might just put the light back together just in a box and just continue to use this to run it. Because I mean, I know where the inputs and the outputs are. So that is 220K, 250 cents, a 250 volt, 22K. So that's 0.22 microfarads at 250 volts, which that might actually be the input capacitor, considering we have 120 volts wall where I live. Let's see if we can't get some of this stuff off the transformer. Oh yeah. The transformer's not actually that large. Nope. This is a 0.031, 0.032 rather than a 0.064 board. Wonder why they chose a thinner board. Maybe it was just cheaper. There's a number of pads on this board that are not populated. It's rather interesting. I wonder if this board is used in multiple lights. See, like there's R27 right there. Nothing on it. Wouldn't surprise me if they have one kind of switching board and then they have a couple configuration options they can stuff it for. Keeps the parts cost down, you know, having common stuff, at least the board costs. Well, I've got most of the epoxy off, or silicone off at this point. This thing is remarkably complicated, considering I'm pretty sure there are single chip solutions that'll do everything it does. It has at least 4 transistors. There's an empty space over here that's designated Q8. You can see there's a little SOT223 device, Q1 there. There's a big TO252 device here. Got a big output capacitor. There's presumably something under here. Lots of devices. There's the bridge rectifier. Here is presumably the control IC. It's a 10-pin device. Let's see if we can't make out what that says. Hold on, let me change lenses. Alright, so here we are. Here's the board. So that is an U1 is M98 SZBB, I think. Could be S7. It's definitely M98. It could be S788. It's an SC. Could be an S2, 8 or B. I can't tell what those are. Fortunately, the chip's kind of grungy. Yeah, so it's an SZBB. So you can see here's the rectifier. So you've got positive. That's nice. They've actually bothered to label the inputs and outputs. So you've got AC on this side. So that kind of confirms my belief that all of this. See, because here's one channel AC which goes here, and the other one goes to that, which runs over into one of these film capacitors. So I'm pretty certain that this whole segment here is input filtering. You've probably got a capacitor across the line, series inductors, capacitor across the line. You know, this is all UL rated stuff. Blah blah blah. And then over here you go out, and then the 2 output connectors are going to this capacitor right here. So this is 823, so that's 82 nanofarads at 250 volts. So yeah, I think this thing is indeed not, I don't think it's continuous. I think it runs, or the brightness is probably related to the line voltage. So then down there we see there's a, whatever that is, that's hardly labeled. It just says S18 on it, I think. And continuing on over here, we can see part number information. Let me get that last bit of resin off of it. PCB 00167 Rev D. So this is a pretty tried and true design. There's another transistor. Some more unpopulated stuff. Seems to be it's a 603. It's not that tiny. You can see there's Q8 down there, which is this unpopulated footprint. Lots of diodes. There's 2 diodes there. That's a transistor, I think. These are interesting. These are this is 1206. So I wonder why. I bet that's like dealing with line voltages, and they needed the creepage distance. So over here, here's the output, and I think this and this are presumably the rectification. These 2 diodes are rectification on the output of the transformer. You can see also over here there is a very large, I could have sworn I saw a very chunky resistor. Where did I see that? So let's see. So one of our output terminals is right here. There's nothing down there. Though it is interesting, it looks like there is an actual gap in the PC board, which is strange because I don't think they need to worry too much about creepage because it's not isolated. It might be isolated. That's really interesting. I mean, because look, they definitely cut a groove into the circuit board. And I don't see any optos, but anyways, here's the, so I don't know how they're getting feedback. Here's the main switching transistor, I think. K2R6 something, 1 second. K2R6D0 or 600, I think it's a D. Barely marked on there. It's in a TO252 package. Transistor. So this appears to be bridging the insulation gap. But I'm beginning to think this thing has an isolated output, which is really interesting. I wonder why they bothered with that, considering that it doesn't need it. And for that matter, how are they accomplishing the... yeah, definitely. Look, you can see through the gap there. Also, cute little fiducials with net labels. Or, well, part labels. So I wonder if this thing is... I wonder if they're just putting in a certain amount of power and just kind of assuming it works. I mean, there's one resistor there. That's a 2002, which is a... that's 20K. I don't know what that could potentially be used for. But anyways, the output pins, the transformer only has only has two output pins. So, I mean, they can't, you can't get full wave rectification with only two diodes unless you have a center tap, and they don't. All they have is this big electrolytic, which might smooth. Actually, I mean, I think they're probably charging the electrolytic at 120 hertz pulses. But I think they're probably, the output, light output might be continuous because I think this electrolytic probably smooths it out. I guess they're using some sort of current feedback in the transformer or something fancy like that. That's presumably like a 2 kilovolt or 2 kilovolt, something that's legal to have cross the isolation barrier, just to keep the noise down. Fortunately, the silicone kind of sucked most of the ink off of it. It's kind of interesting. You can see that they've got like multiple vias in here, and the board is gold plated, which is really nice, especially for utterly cheap things. So it's very well made. I'm actually quite impressed with this. I mean, there's a lot of stuff in here. I thought it would just be like one transistor, maybe like a funky blocking oscillator or something like that, but they've actually put the time and the effort into it. I wonder what that goes to. Whoops, sorry, that was, so there's one terminal of the line input, and the other one's over here. 94 VO, which means it's rated. More fiducials. What does that say? Sorry, it's hard to focus with this. F303692. Maybe it's well designed because there's, I think, I'm in America and they have, I mean, the laws are kind of shitty. But I think, considering this was sold at a big box store, not like onto the internet, I think if this burns your house down, they expect to get sued, so they're careful. And you can see, look at the size of that ceramic. So I think they probably designed this, with some safety margin in mind, which is kind of nice. And you can see there's big copper pores with multiple vias stitching the two sides together. 3093, that's 309K, and there's two of them in series, so that's probably giving you some sort of isolation voltage or, a breakdown, increasing the breakdown. Yeah. There we go. Is that a diode? What the hell is that? It looks like a... Yeah, I guess it is. That's a diode in a funky little package. It's like a diode in an LED style package. with cache-bladed vias on each end. Haven't seen that before. I think that's a 100 ohm resistor, yeah. So there's 5 pins on the transformer on this end. The transformer is connected between the big. Yeah, they're definitely doing something fancy with feedback in the transformer to get current control. So you can see you've got a really heavy trace running here. Oh, look at that! There's a 1R58. That's a 1.58 ohm resistor. So they're probably doing something related to current measuring, because you can see how this is either ground or VCC. It's probably ground, and then you can see how they've got this. Here's the controllers tied to that, and then that pin is tied to this side of that current measuring resistor. So I'm not sure what use that's going to be, because it. How does the current flow? Because I can't imagine it's flowing through that little skinny trace there to the transformer, or to the transistor. There's a resistor in series. That's 4R1. So there's a 5 ohm. That's a 40 ohm resistor in series with this capacitor across the isolation barrier. Probably just as a protection mechanism in case you have like a AC ground fault or a ground fault somewhere. This thing might produce a lot of common mode noise. There's an 821, so that's an 820 ohm resistor in series with the line, I think. Probably for inrush limiting. Because that's also really big. You can also see originally there used to be 2 big surface mount capacitors here, and they've stuck this big epoxy blob ceramic, I think is what it is. Let me focus. 224, so yeah, that's 0.22 microfarads at 250 volts. Yeah, and there you go. So there's an interesting little constant current power supply from just purchased at my local Home Depot. There's some pretty interesting stuff going on. Look at that, it's even labeled. This is presumably neutral. This is hot, which is what you'd expect from the center. Cool. So there you go. Surprisingly not that cheap AC light fixture driver board. That was an utter nightmare to get out of the case. Hope you enjoyed.